Hi everyone, in this video we're going to go over another Leetcode question, binary tree paths. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start reading the question. Given a binary tree, return all root to leaf paths. Note, a leaf is a node with no children. Example, we are given a binary tree and we need to return all the root to leaf paths. For example, this is a root to leaf path, and this is another root to leaf path. We need to return the output in strings array, and each path as a string. Explanation: all root to leaf paths are 1, 2, 5, 1, 3. So how are we going to solve this question? You can watch other binary tree problems that I solved in my channel. These are like pathsum1, pathsum2, and there are other ones as well. So we use a helper function that's a recursive DFS function to solve this question. Basically what we need to do is this is the given function. The question gives this function, binary tree paths. First thing we check is if the root is null, if this tree exists. If so, we do the search using recursive DFS helper function. We send the root and the string. Let's see the helper function. So this is a recursive function, and we need to implement these 3 steps for each node. The first step is we check if this is the leaf node. Node.left is null, node.right is null. That means this is the leaf node. Then we add path plus node.value to the answer. This is the answer array we created separately. You may see other solutions where they add answer to the parameter, but I prefer this way, so it will be a bit easier for you to understand. After this search BT is done, after this DFS call is done, we finally return the answer in the main binary tree paths function. So if we do it this way, it's easier to understand. And we finally return this answer we created. So we create an answer array list. We fill the array list in the search BT function and return the answer. That's all we do. So this is, if first step, we check if this is the leaf node. If not, we continue. So this string is the path is coming from the previous call, plus the current node value, plus arrow. Let's go step by step and try to figure out. Search BT, first call, root and empty string. Empty string is coming. And path is empty string. So plus node.value is 5 plus arrow. This is our first string. Then we send this path string to the left. All right, so plus. So this is the path we send to the next call. So we did this root, then we are doing the recursion and left subtree traversing the left subtree using this recursion. Then we send it to the left. 5 is sent to the left. So what we do is we check if it's the leaf node or null. No, it's not the leaf node. So continue with the string path plus node path. We add this string to the value. So what we got so far is 5 plus the arrow. What we do is plus node value, which is 4. So we are not doing the plus, sorry, which is 4 plus the arrow, and send this is our new path, and send it to the next recursion, and that would be 4 to 11. So this will be 11. We took the path from the previous call, added the current value, and add the arrow, and do the same for the next one. Seven. Okay, so there is one thing to note here. We send this path to this search BT call again. Now the final check. Node.left is equal to null. Node.right is equal to null. So this is the leaf node. Then we are not adding this again. So the solution breaks here. Then we need to add it to the path. So this is what we do. We add this. Now we add this to our answer array that we created in the beginning, answer list. So now this is our first answer. And if you pay attention, we are not using arrow again, only path plus node value, because the path came from the previous call plus node value added to the answer. Now node returns null. Now we can return back and continue for the other steps. Do the right recursion, do the right subtree, and finally, when all of these is complete, we return the answer here. So this traversed entire tree. Now we return the answer here, and that's pretty much it. That is the answer of the question. So let's see this in the code. Oops. Sorry about it. Oops. Yeah, that's it. So this is the answer we created here. Then list is the binary tree paths root. This is the main function. Check if tree exists. Then call the helper DFS function. In binary trees, we use one main function and one helper function. That's generally how we solve them. And send root and one path string. And finally, when this call is done doing its job, return answer here that we created. So in the search BT helper, check if root is null. I said node in the whiteboard, but this is null. Root, same. Node or root, whatever. Root is null, return. Check if it's a leaf node, and add answer to the add string to the answer list. Otherwise, create your string, path plus root plus the arrow, do the left call, do the right call, and finalize. Let's submit and see if it's going to work. Okay, this seems to work. This is pretty much it for binary tree paths question. I have more videos coming up, so if you subscribe to my channel, we can meet again later. I hope this was helpful. Thanks for watching. Goodbye.